Okay, we're looking at part C now for FRQ 355. So part C says find the acceleration of particle Q at t equals 0. That's easy enough. And then as it says, is speed increasing, decreasing, or neither? So we're going to have to look at both acceleration and velocity at time 2. And remember, speed is increasing when both signs are the same and decreasing when the signs of velocity and acceleration are different. Okay, so that's what you need to know. So first off, we need to get the acceleration of Q. So A Q of t is equal to V Q prime of t, which is equal to 2t minus 8. So then AQ of 2 is equal to 4 minus 8, which equals negative 4. So that was the first part. Now, let's find what VQ of 2 is. So you just put that right into the function. That would be 4 squared minus, not 4 squared, said the wrong thing, 2 squared minus 8 times 2 plus 15, which equals negative 16 plus 15, negative 1 plus 4 is 3. All right, so we had acceleration of negative 4 and velocity of 3. Therefore, the particle must be slowing down. Okay, so let's just answer that. The speed of particle Q is decreasing. Use what they said. They asked increasing or decreasing or neither, because acceleration and velocity have opposite, let's put that at t equals 2, opposite signs at this time. Okay, so let's get the points for this one. You get 2 points for this. You get 1 point for the acceleration, so 1 point for getting negative 4, and you get 1 point for saying it's decreasing with the reason. Okay, so that's 2 points for that. Now let's go on to part D. Okay, part D says find the position of Q the first time it changes direction. All right, so Q was our velocity, one that gave us the velocity. It's the second function. And so we've used a sign chart and saw that it changed direction at t equals 3. So let's say that. The first time the particle changes direction is at t equals 3. So now we need to find its position, and so we're going to have to go backwards using an integral, right? So x q of t is equal to, and now we need to include the initial position because it started out at 5, right? And so if you're trying to find out where it is 3 seconds later, you have to consider where it started. So we write that x of 0. Remember, plus 0 to 3 of VQ of t dt. And remember, these two match, right? It always remembers. And we're not asked for net change. We want to know exactly where it is. That's why you have to use the initial condition. So that's equal to 5 plus 0 to 3 of t squared minus 8t plus 15. This is a non-calculator question, so you have to do it by hand. That'd be 5 plus, and then the integral is 1/3 t cubed minus 4t squared plus 15t. And we want that from 0 to 3. So that would be 5 plus, and this is 9 minus 36 plus 45. and then minus 0. So we get 5 plus 18, which is 23. So we're at 23. So that the answer to that was 23. So let's see where the points are for this. There are 3 points for this. Okay, you get 1 point for using the initial condition, so either here or here, the 5 or the x naught, so x of 0, so you get plus 1 for initial condition. You get plus 1 for the antiderivative, correct antiderivative, and you get 1 point for having the answer. So that is FRQ 355.